Yes, welcome back to the lecture series on functions. We defined in the last video, we looked at what is a function, and I told you that function is a mapping in which no two different ordered pairs have the same first number. Same first number means same x. If I can define the ordered pairs between x and y, then x should not be same for two different ordered pairs. Different means we have a combination of x and y which are different. Either x could be different or y could be different. Now, if the x is same, that means y will be different for two different ordered pairs. And that means the same x value is mapped to two different y values, which is not a function. And a function we saw is either one-to-one or many-to-one. Now, let's look at today as to what type of geometric test we can do to determine whether a mapping or a relation is a function. So sometimes, as I said in the last video also, the relation is defined in terms of a graph. Let's say we have this graph. Now, we don't know the relation between x and y as a mathematical equation, but we still want to know whether this is a function or not. So the definition that we have defined last time will also be the core idea here. The definition is that for same x, we should not have two different y values. So if I have to look at this graph, what is the meaning of having same x value? Same x value, would it mean that I will have to draw a horizontal line or a vertical line? Vertical line is a line which, x is fixed. Let's say this is 3, x is equal to 3 here. Right? So if I want to check that for same x, if there are two different y values on the graph of this, then what I'll do, I'll draw vertical lines through each part of the graph and see whether these lines cut the graph at more than one place. If the graph cuts the graph at more than one place, that means for same x value, which is fixed for the vertical line, given vertical line, there are two different y values, which means it's not a function. Right? So the test is like this. Suppose we draw all possible vertical lines on the graph. If each line cuts the graph at most once, then the graph is a function. If any line cuts the graph more than once, which means for same x value, we are having more than one y value, the graph is not a function. Right? So the very idea that for a given x, we cannot have more than one y value makes us draw vertical lines, because then we are fixing the x and we're trying to see whether that for that given x, are there more than one y. Look at this second one. If I now look at it, draw the vertical lines, you can see every vertical line, in fact, is intersecting the graph at more than one place. For the first vertical line on the extreme left, there are 2 points where the vertical line is cutting the graph. Again, the second line again cutting. That means for this value of x, there are two different y values, isn't it? Which means it's not a function. So that definition has to be very clear, which means that we will draw all possible vertical lines, and if each line cuts the graph at most one, then the relation is the function. Now to make it more clear, can we look at these examples? Now if I draw vertical lines here, you can see they are not cutting the graph at more than one place. You can draw as many lines as you want. The second one, yes, this is also not cutting. But for the third one, if you see that they are cutting the graph at more than one place. That means for the same x value, which is fixed for this line, there are two different y values meeting the curve. Isn't it? That means it's not a function. So that is the very simple way of knowing a function or not a function. Now we look at these examples. This is all, lines not cutting the graph at more than once. Here also. This one, yes, this is also a function. Please see. The fourth one is a graph of an ellipse in which any line that you draw right? We'll be cutting the graph at more than two places. So this is not a function. Here, this is also looking good. Yes. But for this one, f, oh, this is cutting the graph at, the vertical line cuts the graph at more than one place. So this is also not a function. This looks okay. Right? And this here again, you see, these both are dark circles. Dark circles means both are the valid values of y. So if I draw this line, here it is cutting the graph, right, at more than two places. Others are all okay because this is allowed, this is not allowed. So for this line, it's okay. This line, similarly, it's okay. But only this line which is spoiling the game here for the function, and therefore it's not a function. This one, if you look at this, it looks like again a function. Right? So that is how we do. And now, once we have known it's a function, then I told you that we need to classify that as a one-to-one function or a many-to-one function. For that, what I should do? Remember, we were looking at now the y values for the same x value, which we saw there. Now we are looking at, we will draw the horizontal lines now. We draw the horizontal lines and see whether it cuts the graph at more than one place. That means now I'm fixing y and I'm looking at whether it cuts the graph at more than one place. So if the graph or if the horizontal line cuts the graph at more than one place, then it is a many-to-one function, otherwise one-to-one. Now this you can see is a one-to-one function. And every vertical line cuts the graph at only once. Here, if you draw a horizontal line, oh, it is cutting the graph at three places. So this is a function, but what kind of function? Many-to-one function. This was not a function at all, we saw. Right? So this is how it is. So this is a one-to-one function, whereas this is not a one-to-one function, it is a many-to-one function. So for classifying a function as one-to-one or many-to-one, we draw horizontal lines. But before that, we have to draw vertical lines to conclude that the graph represents a function if it only cuts the graph at more than one place. I hope this is very, very clear, right? And that is what is important. One-to-one function is a function in which no two different ordered pairs have the same y coordinate or the second component. So now it's a one-to-one function. Now we are focusing on the same y coordinate, right? Whereas in the definition of function, we said in which no two different ordered pairs have the same x coordinate. Here you see, if you draw horizontal lines, it's only cut the graph at once. Whereas for the quadratic, this parabola, it is cutting at two places. So, you know, y is equal to x squared would mean that when x is 3, then also you get y as 9. And when x is minus 3, then also you get y as 9. So it's many values of x giving us same value of y. So this is a many-to-one function for which if you draw the horizontal line, it will cut the graph at more than one place. So we use the horizontal line test to determine whether a function is one-to-one or many-to-one. Right? And that's what we do. Here it's going to be one-to-one. For this one, I think again, it's going to be one-to-one only. This one is many-to-one. It's cutting the graph at more than 3 places. Right? I hope this is also clear. Now in the next lecture, we are going to cover or start covering the domain and range of the function. Now, which is a very, very core idea and very important for your exams when they start asking you to make a function as one-to-one, right? Or finding the domain and range and then be able to say many things, other things about the functions. So the next class, I hope everyone will see the video, subscribe, like, and share with your friends because we are going to start the domain and range of the functions. Thank you very much.